This is problem 7-69 from section 7.1.4 homework. It says a 5-foot by 4-foot by 3-foot box is made for the purpose of storage. What is the longest pole that can fit inside the box? So let's just think about first, where would that pole be positioned in this box? Now, it's not going to be down here is only 5 feet. I want to think about what would be the longest part of the box. The longest part of my box should be from one of the corners on the top to one of the bottom corners. So either this direction or this direction. They should be the same dimensions, but I want to have it going from a corner to another corner, and it would be a straight pole. So here is going to be my longest pole. So to figure that out, we only know the length, width, and height of the box. Now we need to know kind of something else here. So if that is, let's say that's my hypotenuse. We're going to make a triangle inside of this box. Now I know straight down here, I know that is the same dimensions, that is the same height. Let's just kind of draw in a little dash here. That's kind of like the back of my box. So that's the inside right there. So I know this red is the same as right here. So I know that's 3 feet, but this last part, the bottom of my triangle, say I draw from here to there, now I have a triangle, okay? And if I can figure out the length and height of that triangle, then I can figure out the hypotenuse. So this, again, this red is the height of my box, which was 3 feet, okay? The depth is 4 feet of the box, which doesn't relate to this triangle we drew. The length of the box is 5, which doesn't relate. So we are going to try to end up, our goal is to figure out the height or the length of the green, but in order to do that, I need to know the blue first. I need to know the blue length of the blue triangle. So, in order to know that triangle, I'm going to make a different triangle here, and I'm going to draw in this triangle to help us find the length of the blue side. Okay, so this is the triangle, this is on the ground. So say if I'm cutting the ground kind of in half, or the bottom of the box in half, that's the triangle I'm getting. This should be perpendicular to this side. This is kind of the bottom of my box, the inside the bottom of my box, and this is halfway through it, okay, so that you can kind of look at it that direction. So I'm just going to draw the blue triangle, and I'm going to actually draw it kind of like a normal right triangle. Okay, so we know this is the length of our box is 5, which is right here. Now the depth of the normal box was 4, so that height right here, I know this is 4. Okay, and the hypotenuse I don't know is the blue, and we'll call that side C. So I don't know that, so I'm going to figure that out first, and then once I know that length, I can use it to figure out the green length. Okay, so I'm going to use the Pythagorean theorem to get this. So I have 4 squared plus 5 squared equals C squared. I think the hardest part about this problem, you know where that pole should go in the box, but figuring out how to get there is the challenge. Okay, so I have 16 plus 25 equals C squared. I add those together, and I'm going to have 41 equals C squared. I want to take the square root of that. Okay, so my length of the blue is the square root of 41. That's the length of the blue. So now if I go back up into my triangle, I'm going to look at the red, blue, and green triangle. Okay, so I'm going to redraw that one, maybe over here. This is now, I have a right angle right here between these two. Okay, so I'm going to draw my red, the length of this, I know, I just figured that out, and the green is really the answer to this final question, what's the longest pole that can fit inside the storage box. Alright, so here's our right angle. So we just found out this blue side was the square root of 41, and we can change it into a decimal if we want, but let's just wait because we're going to end up squaring it again. And I know this red right here was the height of my box, which is 3, and I need to find out side, we'll call this side D, so we don't get confused. Okay, so now, draw that down here, I'm going to do the same thing, Pythagorean theorem. I'm going to take 3 squared plus the square root of 41 squared equals D squared. So that D value is where my longest pole is going to fit. So I have 9 plus the square root and a squared cancel each other out, so I just have a 41 right here equals D. So I really have, oh, D squared. So I really have 50 equals D squared. Take the square root of both sides. The square root of 50 is going to be about 7.07. And that's going to be D, which is cutting straight across, straight through from the top corner of the storage box to the bottom corner. Now, this should be the same as if you're going here or over here. It doesn't matter which corner of the box you start from. Same thing as going here and ending up in the back. From any top corner to any across the way bottom corner, the longest pole I could fit in is going to be 7.07 feet. Okay, we were in feet. So I'm going to find, I used 2 triangles to find this. I started with kind of this black one on the ground, and that's over here. So I had to find the hypotenuse of that side first, and then I can use that to kind of get my triangle. If you can visualize the red, green, and blue triangle kind of standing up in the middle of the box, we wanted to find that green side, okay, which ends up being 7.04 feet.